Welcome to today's Coding Talk Nooner. I'm Jim Kunkel, and today we're diving into one of the most misunderstood and most impactful elements of any industrial coatings project, the protective coating specification. Across the industry, specifications are often treated just as paperwork, a formality, or something that gets skimmed once and tossed to the side or left in the work vehicle. But industry best practices make one thing absolutely clear. When coatings are treated as incidental work, the project is already on a path towards costly errors, avoidable failures, and shortened asset service life. Modern protective coatings are complex systems. They demand precise surface preparation, controlled environmental conditions, and disciplined mixing procedures, and also application techniques that leave no room for guesswork. And because of that, the specification becomes far more than a document. It becomes the roadmap for quality, the anchor for consistency, and the foundation for long-term performance. So in today's stream, we're going to break down why a well-prepared coating specification is one of the most powerful tools that you have. We'll look at how it influences, not directs, contractor behavior, how it protects owners and assets, and how it ensures that every step from surface preparation to the final inspection aligns with the performance expectations of the project. If you want to have better protective coating outcomes, fewer disputes, and longer lasting protection, it starts right here with a specification built on clarity, built on competency, and built on industry best practices. Let's talk about why specifications matter more than ever. Industrial coatings have evolved dramatically over the past several decades. The products we use today bear little resemblance to the simple one-part primers and casual scrape and paint approaches that dominated the industry generations ago. Those days are long gone. Modern protective coating systems are engineered materials. They're chemically sophisticated, they're environmentally regulated, and they have a high sensitivity to every variable that the applicator encounters in the field. Industry best practices make this point unmistakably. Today's placement coatings are far more complex in their formulation, in their surface preparation requirements, their mixing procedures, and their application and also curing demands. These systems are designed to deliver high performance, but only when every step of the process is executed correctly. That complexity changes everything. It means the protective coating specification is no longer a formality or a document, like I said, that gets skimmed once and forgotten. It's the backbone of the entire project. It's a technical roadmap that explains to a contractor exactly what needs to be done, not prescriptive. And also understand the conditions, the work, and how it must proceed. It's the anchor that keeps the project aligned with performance expectations, regulatory requirements, and the realities of the service environment. In other words, the specification is the single most important tool for ensuring quality, consistency, and long-term durability. When it's clear, when it's complete, and grounded in industry best practices, it drives success. When it's vague or incomplete, it becomes a root cause of failures, disputes, costly reworks, and legal actions. This is why why they matter more than ever, and why every coating professional from owners to inspectors to applicators, they must treat the specification as a critical project document, just as they truly are. So when it comes to understanding the contracting environment, protective coating specifications don't exist in isolation. They operate inside a broader contracting environment that directly shapes contractor behavior, project incentives, and ultimately the quality of the finished work. If you want a coating project to succeed, you must understand the environment the specification is entering. Industry best practices emphasize that the contracting structure, how the job is bid, awarded, and administered, has a profound impact on how specification is interpreted and it's executed. Let's talk about competitive bid contracts. Now, competitive bid or low bid wins, these contracts are the most common in the public sector and in many private industry environments as well. Now, these contracts reward the lowest acceptable price, not the highest commitment to quality. And that really creates challenges. Industry best practices consistently point out that a competitive bid environment, they're the most difficult to develop a coding specification for because contractors have very little incentive to exceed minimum requirements. When margins are tighter and the competition is fierce, some bidders may cut corners. They might gamble on ambiguous language or rely on change orders to recover cost. This is exactly where a strong, clear, enforceable specification becomes the owner's best protection. A well written specification eliminates loopholes, it reduces ambiguity, and it forces every bidder to price the same work scope. It protects the asset by ensuring that the lowest bid still reflects the true technical requirements of the project. In competitive bid environments, the specification isn't the guidance, it's the barrier that prevents quality erosion. Let's talk about negotiated contracts. Negotiated contracts operate differently. They allow for collaboration, for partner, and alignment between the owner and the contractor. These contracts often produce better communication, more realistic planning, and stronger shared commitment to performance. But industry best practices make one thing clear. Even in negotiated contracts, proactive administration is essential. A negotiated relationship does not replace the need for clarity, documentation, and oversight. The specification still must define expectations, establish quality requirements, and guide the work from start to finish. Negotiated contracts may reduce friction, but they do not eliminate the need for disciplined project management. Now, why does this matter? Whether a project is a competitive bid or negotiated, the contracting environment determines how the specification will be interpreted, how it'll be challenged, and how it'll be executed. Understanding that environment allows owners, engineers, inspectors, and contractors to anticipate risk, to align expectations, and to build a specification that truly supports quality. A coding specification is only as strong as the contracting environment that it's designed for. And when it's built on industry best practices, it becomes a powerful tool for controlling costs, for reducing disputes, and also ensuring long term performance, creating a level playing field. One of the strongest themes reinforced across industry best practices is the importance of fairness and consistency in the contracting environment. A protective coding specification isn't just a technical document, it's a tool that establishes equality, clarity, and accountability for everyone involved in the project. To create a level playing field, the specification must be enforceable. It has to be clear and it must be complete. When those conditions are met, something powerful happens. Qualified contractors bid confidently, and unqualified contractors naturally stay away. The specification becomes a filter that rewards capability and discourages uh, corner cutting. Industry best practice makes this point unmistakable. A specification that cannot be enforced or will not be enforced undermines the entire contracting process. It invites inconsistent interpretations, it encourages risky bidding behavior, and it opens the door to disputes, to change orders, and quality failures. A level playing field isn't just an ethical idea, it's a strategic advantage. Even every bidder knows the requirements will be applied consistently. They price the work honestly, they plan the work realistically, and they execute the work with an understanding that quality expectations are not optional, they're part of the contract. This fairness strengthens the owner contractor relationship. It improves project predictability and it reduces the friction and often plagues coding projects. It creates an environment where the specification drives performance instead of becoming a battleground for interpretation. So, in short, a level playing field is one of the most effective tools for achieving quality, controlling cost, and protecting assets. And it starts with a specification that's built on clarity, that's complete, and follows industry best practices. Roles and responsibilities. A successful protective coding project is never the end result of one person or one document. It's a coordinated effort, an alignment of roles, responsibilities, and professional disciplines working together under a shared specification. Industry best practices make this clear. Quality work is a team sport, and every player has a defined role that directly influences the outcome. So let's break down some of the roles and their responsibilities. The first is the owner. The owner sets the tone for the entire project. Their responsibilities go far beyond funding the work. They're responsible for establishing the expectations that drive quality. Industry best practices emphasize that owners must first provide a complete, accurate, and clear description of the work that they're looking to have done. That they also must enforce all requirements consistently and fairly. And they must coordinate actions among all of the parties. They also manage the project professionally, ensuring cooperation and timely decision making. Owners also carry a critical responsibility, and that's in the selection of qualified contractors. Best practices strongly encourage owners to hire contractors with a proven quality management system or QMS, whether that's an industry certification, accreditation, an ISO 9001 framework, or a documented internal system to themselves that demonstrates discipline and accountability. When owners set high standards, the entire project benefits. Let's talk about the designer. This is the person who writes a specification. Now, they can be an engineer, they can be an architect, they can be a protective coating specialist. They're the architect of the specification, the designer, and their work determines how clearly the project requirements are communicated and how effectively the contractor can plan and price the job. Industry best practices state that designers must create a competent, complete, and technically accurate specification. They must review RFIs, submittals, and clarifications promptly and thoroughly. Ensure clarity, consistency, and also alignment across all project documentation. Now, when the specifications are weak, when they're vague or they're incomplete, the consequence ripples through the entire project. Industry experience shows that poor specifications can lead to unrealistic bids, excessive change orders, dispute between parties, project delays, litigation, and default contracts. A strong specification is the designer's most powerful tool to prevent these outcomes. The contractor. Contractors are responsible for transforming the specification into actual physical work. Their performance determines whether the coding system achieves its intended service life. And industry best practices outline several key responsibilities. First is to plan and schedule the work effectively, provide objective evidence of conformity. That's quality control documentation that proves the work meets the requirements. And they must manage any subcontractors with the same rigor applied to their own crews. They must avoid vague interpretations of the specification and always seek clarification when it's needed. Contractors who embrace these responsibilities, they build trust, they reduce disputes, and they deliver higher quality work. The inspector. Inspectors serve as the project's eyes and ears. Their role is not to catch mistakes, but to provide an unbiased, accurate data that confirms whether the work conforms to the specification. Industry best practices define an inspector's role as observing work as it's performed, assessing conformity to the specification and work plan, documenting results clearly and promptly. One critical point emphasized across the industry that inspectors should not be responsible for the final acceptance or rejection unless they are specifically qualified for that role. Final acceptance often requires a deeper technical judgment, broader project context, and experience beyond basic inspection certification. Inspectors provide data. Quality decision makers interpret that data. Now, why do these roles matter? When each party understands and fulfills its responsibilities, the specification becomes a powerful tool that guides the project towards success. When roles are blurred or responsibilities are neglected, the project becomes vulnerable to miscommunication, quality failures, and costly disputes. Industry best practices reinforce a simple truth: clear roles, clear responsibilities, and a clear specification are the foundation of every successful coding project. Legal considerations. Protected coding specifications are not just technical documents. They are legal instruments. Every requirement, every reference standard, every acceptance criteria becomes part of a binding agreement between the owner and the contractor. Industry best practices emphasize that the legal dimension of a specification is just as important as a technical one because it defines how risk is managed, how disputes are resolved, and how performance is measured. To build a specification that truly protects a project, you must anticipate the legal realities that come with coding work. Let's break down some of the key areas now of where the industry best practices highlight. The first is full performance. Now, full performance means that the contractor must meet every requirement in the specification, not just the obvious ones, not just the ones that are convenient, but all of them. A well written specification makes full performance measurable, makes it enforceable, and it makes it clear. When a full performance is clearly defined, the owner has a strong foundation for quality control and then ultimately final acceptance. Breach of a contract. A breach occurs when any part of the specification is not met. It may have been something missed during surface preparation requirement or an incorrect dry film thickness or a failure to document environmental conditions. Industry best practices stress that even small deviations can have major impacts, especially in high performance coding systems. So, a clear specification reduces the likelihood of a breach by eliminating unclear things and also setting precise expectations. Substantial completion. Substantial completion is a legal milestone. It means that the project is functionally complete, even if minor nonconformities remain. Industry best practices define substantial completion as a condition where deviations are not material to the performance, and they could be addressed through corrective actions or maybe even contract price adjustments. A strong specification helps determine what is minor and also what is material, preventing disputes in the project at the end of the project. Now, claims Claims arise when one party asserts a right, usually money or time, based on contract obligations. Claims often stem from unclear specifications, differing interpretations, or undocumented conditions. A well structured specification minimizes claims by defining responsibilities, by documenting requirements, and establishing procedures for communication and resolution. Um, mechanics liens protect contractors and suppliers who are given them as a legal interest in the property. If payment issues arise, owners must understand how liens work and ensure that documentation, payment schedules, and performance verification are aligned with legal requirements. Specifications that clearly define payment conditions and documentation expectations help prevent lien disputes and dispute resolution. Disputes can arise from differences in interpretations, unexpected site conditions, or disagreements over the conformity of the project or elements of the project. Industry best practices encourages specifications to outline preferred dispute resolution methods, whether through negotiation, mediation, arbitration, or direct litigation. Clear dispute resolution language keeps small issues from becoming major conflicts. Indemnification. This is a clause that defines who's responsible for the damages, for the losses or liabilities that arise from the work. In coatings projects, this can include environmental impacts, safety incidences, or failures caused by improper application. A specification grounded in best practices ensures identification language that it's fair, that it's balanced, and it's aligned with the realities of protective coatings work. So, why do these legal factors? Why do they matter? What I had gone through, they're just not simply legal terms. They're really risk factors that every specification must anticipate. When a specification is vague, when it's incomplete, or becomes unenforceable, these risks multiply. When a specification is clear, comprehensive, and aligned with industry best practices, these risks are controlled. A protective coating specification is both a technical roadmap and a legal safeguard that protects the owner, that guides the contractor, and ensures the asset receives the performance it was designed for. Corrective and preventive action. This is one of the most powerful concepts that reinforce really across industry best practices is really the use of disciplined use of corrective actions or CAs and preventable actions or PAs. These two mechanisms form the backbone of quality management and protective coating projects. They keep the work on track, they eliminate recurring problems, and they enforce that the specification is not just a document, it's a living standard that guides performance. So let's break them down. First, let's talk about a corrective action or a CA. Corrective actions are reactive, but they're also structured, they're deliberate, and they're essential. When a nonconformity occurs, whether it's an improper surface preparation or incorrect mixing or inadequate environmental controls, or even a failed inspection, a corrective action needs to step in. The industry best practices associated with it show that the process identifies the root cause of the nonconformity. It works towards eliminating that root cause through a targeted action, and then it prevents the issue from reoccurring by verifying the effectiveness of the correction. Corrective action is not about blame. It's about understanding why something went wrong and ensuring that it never happens again. In high performance coating systems, where small deviations can lead to major failures, corrective actions are one of the most important tools for protecting the asset on the project. Now, preventable action. These are proactive, and it uses experience, data, and professional judgment to stop problems before they occur. Preventive, preventive action is about anticipating the risk, strengthening the process so that nonconformities are going to be hard to materialize, if never materialize. Now, industry best practices describe preventable action as a process that analyzes trends, looks for patterns, and also details past issues. It also identifies potential future problems, and you implement proactive measures on how to avoid these problems entirely. Preventive action is a hallmark of a mature quality culture. It reflects a mindset that values foresight, that values planning, and values continuous improvement. So, why do corrective actions and preventable actions matter? So, together, the corrective action and the preventative action, they really form the heart of quality management in protective coatings work. They ensure that problems are not repeatable, the processes improve over time, documentation supports accountability, the specification remains a central reference point, and the project stays aligned with industry best practices. Corrective action and preventive action transforms the specification from a static document into something more dynamic. It's going to be a quality system. It's one that adapts, learns, and strengthens the project as it progresses. So basically, the corrective and preventative actions are the mechanisms that turn good specifications into great outcomes. They protect the owner, they support the contractor, and they ensure that the coating system performs the way it was truly designed for. Now, let's talk about building the specification itself. When we talk about protective coating specifications, we're not talking about a simple document. We're talking about a blueprint for coating project success. Industry best practices emphasizes that a coding specification, it needs to be structured, it needs to be coordinated, and it has to be comprehensive. It must anticipate the realities of the job site, align with the broader contract documents, and provide clear technical direction from the first surface prep step to the final acceptance. A built specification eliminates unclear aspects. It reduces risk and it ensures that every contractor is pricing and planning the same work. So let's break down some of the essential components that industry best practices highlight. The first is the coordination requirements. A coding specification cannot stand alone. It must integrate seamlessly with the rest of the project documentation. Industry best practices stress that specifications must align with general conditions, Division 01 requirements, and also front end documents. This coordination it ensures that scheduling, safety, submittals, communication protocols, and administration requirements are consistent across the entire contract. And when these documents conflict, the project suffers. When they align, the specification becomes a powerful tool for clarity and control. Foundation standards. Every coding specification must begin with the correct foundational standards. These standards establish a baseline expectations for the surface preparation, the coating application, the inspection, and the expected performance. So, industry best practices recommend for steel coating projects, you want to begin with a recognized general painting specification that's built, written for steel structures. And then for concrete coating projects, you want to begin with a recognized general painting specification for concrete surfaces. These foundational standards provide the framework upon which all project specific requirements are built, and they ensure consistency and reduce interpretation errors. And also, they anchor the specification in proven industry methodology. Now, the key elements of the complete specification. A high quality coding specification is detailed, it's structured and comprehensive. Industry best practices outline a wide range of elements that must be included to ensure clarity and enforceability. First is the scope of work. Also, too, areas to be coded and areas not to be coded. Site access and logistical constraints, and also reference standards and governing documents. Required submittals.
safety and health work plans, work plan and process control procedures, quality assurance and quality control requirements, delivery, storage, and handling of materials, hazardous materials management, ambient condition requirements, surface preparation requirements, application requirements, inspection and documentation procedures, final acceptance criteria, and warranty requirements. This list is extensive because the coding projects are more complex today. Every one of these elements plays a role in ensuring that the contractor understands the expectations for the project and that the inspector knows what to verify and the owner has a clear basis for acceptance. Industry best practices often provide detailed checklists to help designers, specification writers, to ensure nothing is overlooked. These checklists are invaluable. They transform the specification from a simple document into a comprehensive project roadmap. So, why does this matter? A coding specification built on industry best practices is more than a set of instructions. It could be a technical guide, a legal safeguard, quality assurance tool, communication framework, and a risk management instrument. When the specification is complete, coordinated, and enforceable, it becomes the backbone of the entire project. It drives consistency, reduces disputes, and reassures that the coding system performs as intended. So a strong specification doesn't just support the project, it clearly defines it. Now let's close out this stream and talk about um, a coding condition survey. When it comes to maintenance coding decisions, few tools are valuable or sometimes overlooked as coding condition surveys. When often it's referenced as a CCS, industry best practices consistently emphasize that a CCS is not just a preliminary step, it's a critical diagnostic process that informs every decision about repair, overcoating, or a full removal and recoat. A coding condition survey provides factual foundation for determining what the asset needs, what the existing coding can still deliver, and how to design a specification that aligns with real world conditions rather than just assumptions. So let's break down what a high quality condition coding condition survey has. Um, some of the documentation of, or you want to document existing coding conditions. So you want to begin with a thorough evaluation of the current existing coding system, and you want to mark down visible defects, log that down, adhesion performance, film thicknesses, surface contamination, and areas of corrosion and under film deterioration. This documentation is really essential because it establishes the baseline condition, the visual conditions roughly of the asset. Without it, really any maintenance plan is guesswork. You also want to assess the remaining coding life. And industry best practices stress that the importance of determining how much service life that there is in a coating. And typically, what the assessment will consider is the coating age, the environmental exposure, its performance history, and how it's faring. Is it deteriorating or is it in relatively good or fair condition? Now, by understanding remaining life, it helps owners avoid unnecessary removal and ensures maintenance dollars are spent wisely. You also want to evaluate the suitability for overcoating. One of the most important outcomes of a coating condition survey is determining whether the existing coating can support overcoating. And this evaluation will include adhesion testing, compatibility considerations, surface profile assessments, identification of marginal or unsound areas, and industry best practices strongly caution against premature removal of sound coatings, especially older lead based primers that may still be performing well. Removing a coating that is still structurally sound, it wastes resources and it may introduce unnecessary environmental and safety challenges. So, context matters. A coding condition survey provides that context. Now, when it comes to developing technical recommendations, the coding condition survey should conclude with a clear, actionable recommendation that guides the specification and maintenance strategy. These recommendations may include full removal, partial removal, spot repairs, overcoating, surface preparation methods, coating system selection, environmental controls, inspection requirements. And these recommendations transform the coding condition survey from a diagnostic tool into a planning document. So, why do these surveys really matter? Because they're a bridge between the asset's current condition and the specification that will define its future performance. So, without a coding condition survey, owners could risk overspending, underprotecting, misdiagnosing failures, selecting incompatible systems, removing coatings that should remain, and overlooking hidden deterioration. When a coding condition survey is grounded in industry best practices, maintenance decisions become smarter or more cost effective and more aligned with long term asset protection. So, a coding condition survey doesn't just inform the specification, it strengthens it. Now, some of my closing thoughts on this broadcast. So, as we wrap up today's stream, it's important to recognize that industry best practices make absolutely clear that a protective coating specification is far more than a technical document. It's a management tool, a legal instrument, and a roadmap for achieving quality across every phase of a coating project. A well-written specification does more than describes products or procedures. It establishes the expectations, it defines the responsibilities, and it creates the structure that keeps the project aligned with performance goals. When built on clarity and industry best practices, a specification becomes a powerful force multiplier. It creates fairness by ensuring that every bidder prices the same work. It reduces risk by eliminating unclear elements and aspects and also potential loopholes. It improves performance by guiding contractors, inspectors, and owners towards consistent execution. It controls cost by preventing unnecessary change orders and disputes, and extends service life by ensuring that the coding system is applied exactly as designed. But the opposite is also true. When a specification is vague, when it's incomplete or unenforceable, it becomes the root cause of project breakdowns. Poor specifications lead directly to misinterpretations, disputes, quality failures, cost overruns, wasted resources, premature coding failures, legal entanglements. In other words, the strength of the specification often determines the strength of the entire project. A protective coding system can only perform as well as as the specification defines it. When the specification is grounded in industry best practices, then it's clear, it's concise, it's coordinated, it's enforceable, and it's complete. It becomes the foundation for long-term foundation and also asset protection and project success. Wait, let me read this one here. Who normally holds a contractor accountable to the performance of the coating? Well, hopefully, on something like this, when you're looking at project work, if things start to become apparent to anyone involved in a project, there needs to be some intervention to happen. You typically, if you see something that's going the wrong way, it's best to do your time out, stop, and be able to correct it because you don't want to wait until the problem actually you're past the problem, and now all of a sudden you've got a lot of issues with rework or other things. Hi, all, and thank you very much. So, in closing, I appreciate this opportunity to have this conversation with everyone, and looking forward to have additional. what I highly recommend everyone to do is, if you're not currently subscribed to the Codings Talk Insight articles on LinkedIn, please subscribe to that. We just went over 5,000 subscribers, and I appreciate everyone who is subscribing it, who comments on it, who shares it, and recommends also to me topics that I should cover. All right, everyone, have a good rest of your afternoon, your evening, or morning, no matter where in the world you're watching this broadcast.